Number 1 asks us to select all the points on the graph of the equation 4y minus 6x equals 12. So in order to be on the graph, these points need to be a solution to this equation. So remember that the x comes first and the y comes second, and we will just plug those in here. So we need to do 4 times the y coordinate, so 4 times -3, minus 6 times the x coordinate of -4, and that needs to equal 12 if it's a solution. So 4 times -3 is -12. -6 times -4 is +24. And then -12 plus 24 is 12. So 12 equals 12. A is a solution. B, we'll do the same thing. So 4 times the y coordinate of 1.5 minus 6 times the x coordinate of -1, and we'll see if this equals 12. So 4 times 1.5 is 6. -6 times -1 is +6. And 6 plus 6 equals 12. So B is a solution. C, so 4 times the y coordinate of -2 minus 6 times the x coordinate of 0. Does that equal 12? 4 times -2 is -8. -6 times 0 is 0. And -8 does not equal 12. So this is not a solution. D, 4 times the y coordinate of 3, and then minus 6 times the x coordinate of 0. Does that equal 12? 4 times 3 is 12. -6 times 0 is 0. And 12 plus 0 is 12. So D is a solution. E, 4 times -4 minus 6 times 3. Does that equal 12? So we have -16 is 4 times -4. -6 times 3 is -18. And that does not equal 12 because this would continue to go further negative. It would be at -34. F, so 4 times the y coordinate of 4 minus 6 times the x coordinate of 6. Does that equal 12? 4 times 4 is 16. -6 times 6 is -36. And that does not equal 12. So that is not a solution. Number 2, now we have a graph of this equation, and we want to decide if these coordinate pairs are solutions. So to be a solution, the ordered pair would need to be on this line. So we'll go to the point 0, 2. So we go 0 in the x direction, 2 in the y direction. That one is on the line, so it's a solution. B is the point 0, 6. And 0, 6 is not on that line, so that one won't be a solution. C is the point 2, 6. So we'll go 2 in the x direction, 6 in the y direction. That one is not on the equation or on the line. 3, 1. So the ordered pair 3, 1 is on the line. So that one is a solution. The ordered pair 4, 1 is above the line. So that is not a solution. And then the last one here, so let's do it in yellow, 6, 2. So here's goes 6 in the x, 2 in the y. That one is not on the line either. So that one is not a solution. Number 3, a theater is selling tickets to a play. Adult tickets cost $8 each, and children's tickets cost $5 each. They collect $275 after selling X adult tickets and Y children's tickets. What does the point 30, 7 mean? So 30 is our X coordinate. So this means that we sold 30 adult tickets. And then 7 is our Y coordinate, which is our children's ticket. So we sold 30 adult tickets and 7 children's tickets. And since it's on that line, we know that that totaled $275. Number 4 requires technology. You can use Desmos if you want to graph this, or if you have a graphing calculator. So it says Priya starts with $50. So she starts with $50 in her bank account, then deposits $20 each week for 12 weeks. Write an equation that represents the relationship between the dollar amount in her bank account and the number of weeks saving. So at week 0, she's got that $50, right? At week 1, she has the 50 plus she's put $20 in. At week 2, she has $50 plus she's put 2 20s in, because each week she put 20. At week 3, she has her initial 50 plus she's deposited $20 3 times. And then at 4 weeks, she'd have 50 plus she's deposited $20 4 times. So this number, the number of 20s changes per week. So we could write an equation, something like the money that she has equals 50 plus the number of weeks times 20. So you could write it that way. You could also write it 50 plus 20 times the number of weeks if you'd rather have the number in front of the variable. Then part B asks us to graph this equation. So graph it on Desmos or in your graphing calculator, and you'll get this line. So you want to go to 12 weeks, and then you want to change your Y scale to be able to see, this one changes up to 320. And then it says, mark the point on the graph that represents the amount after 3 weeks. So at 3 weeks, we go up and plot it on our line here. Okay, so there's the one for 3 weeks. And at 3 weeks, right, she'd have 50 plus she'd have 20 times the 3. So she'd have 50 plus 60. So that Y coordinate, or the amount of money in her bank account, is going to be $110. Then C asks us to find when she will have $250. So then we look to the Y axis to go to 250, so about here, and we go over until it hits the equation, and then we look down and see how many weeks that would be. So this is telling us that she will have $250 after 10 weeks. And you could certainly check that by calculating 50 plus 20 times 10. And 20 times 10 is 200, and 50 plus 200 is that 250. Number 5, during the month of August, the mean daily rainfall of one city was 0.04 inches with a standard deviation of 0.15 inches. In another city, the average rainfall, or the mean rainfall, was 0.01 with a standard deviation of 0.5. Hans says that both cities have a similar precipitation pattern for the month. Do you agree? So it appears here that these cities both have very little rainfall. Okay, so yes, both cities have very little rainfall. Less than 5/100ths of an inch. This one's at 0.04 and this one's 0.01. So yes, both cities have very little rainfall in August. But the first city has quite a bit of deviation or variation in the rainfall, which might suggest that that city had a few very rainy days, with most days having almost no rain, versus this other one was just kind of consistently a little bit of rain, because there's not very much deviation here. But both very little rain, just maybe a couple of days that are rainy in that first city. And you could say other things. That's just kind of what I'm saying. Number 6, in a video game, players form teams to work together to earn as many points as possible. Each team can have between 2 and 4 players. Each player can score up to 20 points in each round of the game. Han and 3 of his friends, so there's 4 people total here, decide to form a team and play a round. Write an expression, an equation, or an inequality for each quantity described here. If you use a variable, specify what it represents. So the number of allowable players on a team. So the allowable number of players on a team. And remember, we can have between 2 and 4. So 2 has to be less than or equal to the number of players, which then has to be less than or equal to 4. So the players need to be between 2 and 4. So that's one way to write it. N is bigger than or equal to 2, if you read it that way, and N is less than or equal to 4. And then N being the number of players. So then in part B, it says the number of points Han's team earns in one round if every player earns a perfect score. So Han's team, remember, is 4 people. So there's 4 people, and the max score they can get is 20 points. So if every player, all of his 4 players, each score 20 points, that'd be 4 times 20. C, the number of points Han's team earns in one round if no player earns a perfect score. So I would say here that your max score per person is 19 points, right? Since nobody can get a perfect score. So then an expression for this would be 4 times 19. So your score or your points needs to be less than or equal to 4 times 19. And then P being the number of points scored. D, the number of players in a game with 6 teams of different sizes. 2 teams have 4 players. Okay, so 2 teams have 4 players, and the rest have 3 players. So we've already used up 2 of our 6 teams. So then there's 4 teams left, and each of those teams has 3 players. And then the number of players in a game with 8 teams. So remember, the players have to be between 2 and 4. So I would say our minimum number of players here would be if every team had 2, and we have 8 teams. So 2 players times 8 teams would equal 16 for our min. And then our maximum number of players would be if all the teams had 4. So 4 times 8 would be 32. That's going to be our maximum amount of players. So our number of players here is going to have to be 16 for our lower end for the number of players. And then that's going to have to be less than or equal to 32. So the number of players is going to be between 16 and 32. Number 7, a student on a cross-country team runs 30 minutes per day as part of her training. Write an equation to describe the relationship between the distance she runs in miles and her running speed in miles per hour. So remember that distance is going to equal her rate times her time. Remember that our time here is in hours, but she's running in minutes. So we're going to have to convert that. So remember that there are 60 minutes in every hour. So if she's running at a constant speed of 4 miles per hour for 30 minutes, 30 out of 60 for the hour, right? So 30 minutes out of 1 hour. So 4 times 30 over 60. And you can certainly simplify that if you want to. So you could say 4 times 1/2 or half of an hour, right? 30 minutes is half an hour. At a constant speed of 5 miles an hour for the first 20 minutes, remember 20 out of 60, plus then 4 miles per hour for the last 10 minutes. So 10 out of 60. And again, certainly you can simplify those if you want to. I'm not going to. At a constant speed of 6 miles per hour for the first 15 minutes, so 15 out of 60, plus then 5.5 miles per hour times 15 minutes again out of 60. D, a constant rate of speed for A miles an hour. So her speed is A. Her time is 6 out of 60 minutes. And then a speed of 6.5, or her rate, times 24 out of 60 minutes. Part E, at a constant speed of 5.4 miles per hour for M minutes. So remember, that's still minutes, so we need to do out of 60. And then a speed of B miles per hour for N minutes. So N out of 60. Number 8, in the 21st century, people measure length in feet and meters. At various points in history, however, people measured length in hands, cubits, and paces. There were 9 hands in 2 cubits, and there are 5 cubits in 3 paces. So let's write an equation to express the relationship between hands and cubits. So I'm just going to make a table here so we can look at the relationship. So hands versus cubits. So up here it said there's 9 hands in 2 cubits. So I like to figure out what is the relationship here. Okay, so what are we doing to multiply to get from 2 to 9? And so you can figure that out, or you can divide by 2 to get down to 1. So if you divide this by 2 to get to 1, then we need to divide this by 2. And 9 divided by 2 is 4.5. So that helps you to easier see that you take the cubits times 4.5 to get the hands. So if we had C cubits, so if we put, let me make another table. So if we were looking at how many cubits for hands, so if we just had C cubits, we would multiply that by 4.5 to get hands. So this would be your equation. 1 hand equals 4.5 cubits. So that would be your equation. So now in this next one, we are looking at the relationship between hands and paces. So the connection here was they gave us cubits to paces. So let me first get cubits to paces. So that was 5 to 3. And so I want to get down to how do I go from paces to cubits? So if I take here and I divide by 3 so I can get down to 1, then 1 pace equals 5 divided by 3 cubits. So then we can see that in order to get here, we multiply by 5/3. So if I had, so let's put this into a larger table to kind of connect this. So here we have cubits to hands, and then we also did paces to cubits. So to go from paces to cubits, we multiplied by 5/3. Okay, that's what we found here. And then for cubits to hands, we multiplied by 4.5. So if I want to connect paces all the way over to hands, I would take the paces times 5/3, and that would get me to cubits. Then I need to take this and multiply it by 4.5, and you could type that in your calculator. But 5 divided by 3 times 4.5 is 7.5. So then you get 7.5 paces for, you multiply 7.5 times the paces to get the hands. So the equation is hands equals 7.5 times however many paces you had. Number 9, the table shows the amount of money A in a savings account for M months. Select all equations that represent the relationship. So we just want to look at these relationships and plug in values. So this says that our dollar amount, okay, that's here, is going to equal 100 times M. Well, 5 times 100 is equal to 500, not 1200. So this is not going to work. The next one says that we would take 100 times the month. So if I just plug in the first one, 5, 100 times 5 minus 5, well, that's 0 because this is 0, and 100 times 0 equals 0. So that doesn't equal the 1200 it's supposed to. Part C says that I will take the amount minus 700. So let's go over here. So the amount for this first one is 1200 minus 700 should equal 100 times the month that went with it. Okay, so 100 times 5. 1200 minus 700 is 500. 100 times 5 is 500. And then I like to check it a second time. So that's true for this one. Then I check the second one as well, or the next one. So the next one is 1300. Whoops. So we have 1300 minus 700, and 1300 goes with 6. So this should be 100 times 6. 1300 minus 700 is 600. 100 times 6 is 600. So I know this one is true. Now, if C is true, then D can't be true because this one is subtracting 1200. And we know that we subtract 700 to get 100M. So D is just automatically not true. E says the amount is going to be equal to 700 plus 100M. So in our first one, again, our amount is 1200 would equal 700 plus 100 times 5. And that's 700 plus 500, which is 1200. So then let me try it again for 6. So at 6, our amount is 1300. Does that equal 700 plus 100 times 6? And 700 plus 600 is 1300. So this one is true. So again, that means F can't be true since it puts the 1200 in here. And then that final one is saying 1200 plus 100 times M minus 5. So 1200 plus 100, our month 5 minus 5. And remember, the amount for this one is 1200. It's that first one here. So 1200 equals 1200 plus 0. This is 0, so that's true. And then let's try it for 6. So 6, the amount is 1300. And then 1200 plus 100 times 6 minus 5. So that's going to be 1200 plus 100 times 1, which is 100. 1200 plus 100 is 1300. So that one's going to be true.